Good morning, everyone. Welcome to our presentation for the Hackthon. Our team is s2mile, stands for Scalable and Secure Machine Learning in edge computing. Our team consists of 4 members. They are Haolong Xiang, Wenwen Gong, Xiaoxiao Qi, who are PhD students at the Macquarie University, and Dr. Xun Zhang, who is working, who is staff in the department. Our attempted challenges is number 2, that is the long-term units marking assessment. We first just state the problems. We actually focus on the effects of the market distribution on the predictions. We explore the market distribution for different data sets. Then we found that actually the market distribution for some data sets are not reasonable. For example, in AC3, the marks 3, which is the highest mark, actually takes many data instances. This means that the students, many students will obtain HD grade. So this is actually unreasonable because at the end of the semester, usually the examiners needed to write a report to explain why there are so many HDs. We also observe the same phenomenon in the other data set. Here we show another data set, AC7s. So to summarize, the pinpoint we have in the markings is that the market distribution is not good enough. It is not good enough. Too many HD and F that make the markers kind of painful because they have to do some rescaling in order to control the rate of HD or F. The reason behind this is that because the marking is usually done with respect to the rule-based rubric, which is usually made when the assignment is published. But the students' submissions can vary wildly because of their different background. Also, usually the lecturers might not understand the student's background well. So the assignment might be too hard or might be too easy for the students. These kind of things can result in the abnormal the abnormal market distribution. This will make some prediction models perform poorly. For example, for the challenge-2 dataset, we actually use the XGBoost regression for some direct prediction after we performed the feature extractions. This figure shows the result for 2 linear regression model, XGBoost and the ordinary linear regression. While the 2 regression models performs relatively good on most of the data set, but we found that for AC7 and AC8, actually the errors are kind of unreasonably big. So the observation actually complies with what we have just analyzed. That is, unreasonable marking actually affected the prediction performance. So then our following work is to try to mitigate this kind of problems. We want to let the marking rubric more flexible, so the markers can actually do the marking after the student's submission, with respect to some adjustment on the rubric. In order to achieve this, the markers needed to identify the boundary of the student submission. So here the boundary means the markers needed to know the good student or the good submissions or the bad submissions. Then this can help the markers to rescale or to adjust their marking. So in order to detect these two extreme case, very good markings and very bad, very good submission and very bad submission, we needed to use anomaly detection method for these two types of extreme values. So our solution for this is to use the framework named LSHI Forest, which was proposed by our team. This is an anomaly detection framework that can identify the extreme values. So these figures show the general workflows, how our training stage and how the testing stage works. We do some feature extraction with the faster text on the input data, and then we trained the model. After we get the trained model, we just run the prediction to get the marks, to get the anomaly scores for each data instance. And then we compare with the ground truth. That is the original mark of the submission. Then we can calculate the AUC scores. So the AUC score is a good performance for anomaly detection. The higher AUC score means the detection result is better. That is, we can easily identify the very good students and the very bad students. So with the trained model, we can just do the prediction in the unsupervised manners. Here we just show the process of the pre-processing of data. We convert the text data into the numerical vector by fast text. And then we just do some discretization manually to get the outlier and the normal points. Here we show some examples for the converted feature values and the label values. Finally, here we would like to demo our evaluation result. We choose 4 instances of our isolation forest anomaly detection method. On the 7 dataset, we just ignore the AC4 dataset because it contains some format errors. So the AUC score here are relatively good, means that our detection method is effective on detecting the very good students and the very bad students. So after identifying these students, the markers can manually explore how bad submission and how good submission look like. Based on that, then the examiner will be more confident to do the marking and produce more reasonable marker distributions. So this is how our work can help the markers, can assist the markers in producing more a fair and more reasonable market distribution markings. Okay, thank you so much.